All right, so trig is based a lot on the unit circle. And the unit circle is when you have a circle whose radius is 1. So you can see here, if you go from here all the way over to here, you've gone 1 unit. So the units of this particular point would be 1, 0. And here, if I go up, this would be 0, 1, because I'm going 0 in the x direction and 1 in the y direction. If I go over here, it would be -1, 0, and all the way down is 0, -1. So that's how you get those 4. And how you get all these other ones going around is if you draw a triangle right here. So this radius here would be 1 because, right, all the radii are 1. If I just kind of dropped this down and made a right triangle here, this here would be 30 degrees. And I want to know, well, what is this x value right here? Well, I know that this is 1, and I know this is a 30, 60, 90 triangle. So I know opposite my 30 is going to be x. This would be 2x. And this would be x times the square root of 3 if I'm using my 30, 60, 90 triangle pattern. So if my hypotenuse is 1, I know that I have to say 2x equals 1, so I know that x is going to equal 1/2. And then over here, this side here is going to be 1/2 times the square root of 3, or I can write that simply as the square root of 3 over 2. So now I know that these sides here, this side is the square root of 3 over 2, and this side over here is simply 1/2. So if I take a look at what that means as my unit circle is concerned, this here is 1/2. If I say, all right, well, then what are the coordinates of this point right here? Well, I'm going over this amount in my x direction. So I'm going over the square root of 3 over 2. So that's that point. And I'm going up 1/2. So I'm going to be going over, so square root of 3 over 2y. That's my x and my y value. But if you think about it even a little bit more, well, the sine of 30 degrees, we know, is 1/2. And we know the cosine of 30 degrees is the square root of 3 over 2. So we know going around this circle that all of these points is always going to be the cosine and the sine. So this would be the cosine of 45. This would be the sine. This would be the cosine of 60. This would be the sine. This would be the cosine of 90. This would be the sine, and so on and so forth. So all these coordinates are giving you the sine and the cosine. The other thing that's important to remember, well, let's actually jump to our unit circle and start filling it in. So it's kind of important that you understand where all of the values from the unit circle come from. So let's go ahead and just recreate that unit circle ourselves. All right, so we're going to start here. Let's fill out all the degrees going around. So this would be 0 degrees. Again, it's based on our 30, 60, 90 triangles. So this would be 30 degrees. This would be 45 degrees. And this would be 60 degrees. So you can see all your kind of big jumps are going to be 30 degrees. And these little jumps here are going to, each one's going to be 15 degrees. So if I go from 60 up here, I'm taking a big jump. So that's going to be 90. So I'm going to add 30. Again, to go here, I'm going to add another 30. But here now I'm going to add 15 to go from here to here. So this will be 135. And when I go from here to here, I'm going to add 15 again. So this will be 150. Now I have to add 30. So this will be 180. I'm going to add 30 again. So this will be 210. I'm going to add 15. So this will be 225. I'm going to add 15 again. So this one here will be 240. Now I'm going to add 30. So this will be 270. I'm going to add 30 again, so this will be 300. I'm going to add 15, this will be 315. I'm going to add 15, this will be 330. And now I'm going to add again, and this will be 360, which makes sense because I've gone all the way around my circle. Now let's fill in all these blanks, figuring out in radians. So 0 degrees is the same as 0 radians. 30 degrees, again, you could figure it out by saying 30 and then using your conversion factor of pi over 180 and say, well, that's going to be 30 pi over 180, which is the same thing as pi over 6. So I know that this is going to be pi over 6. I also just memorized that 30 degrees is the same thing as pi over 6, thinking that math is always backwards, so the 3 goes with pi over 6, the 6 goes with pi over 3. All right, and then 45 degrees is going to be pi over 4. Right, 90 degrees is going to be pi over 2. And now, if I want to fill in all the 30-degree jumps, I can think, all right, well, this would be 1 pi over 6. This one over here would be 2 pi over 6. But if I reduce that, that's the same thing as pi over 3. If I jump 30 again, this would be 3 pi over 6. But that's going to be the same thing as pi over 2. So this one here is going to be 4 pi over 6. But I can reduce that to 2 pi over 3. I'm going to skip this one. I'm going to jump 30 degrees so I can continue my pattern. This one here would be 5 pi over 6. This one here would be 6 pi over 6. But those 6's cancel out, and that's just pi, which is good because we know that our conversion factor is at 180 degrees, and pi radians are the same things. So this would be 6 pi over 6, so that makes this 7 pi over 6. It would make this one over here 8 pi over 6, but I can divide by 2. So this would be 4 pi over 3. So if this is 8 pi over 6, this one down here would be 9 pi over 6, but I can divide by 3. So this would be 3 pi over 2. So this is 9 pi over 6. If I jump 30 again, I'll have 10 pi over 6, which I can reduce to 5 pi over 3. 10 pi over 6, this is 11 pi over 6, which I cannot reduce. And then over here, I'm at 12 pi over 6, which is the same thing as 2 pi. Now let's go through and do all the same things with all the 45 degrees. So this is 1 pi over 4. This will be 2 pi over 4, which is the same thing as pi over 2. So this here would be 3 pi over 4. This is 4 pi over 4, which is pi. So that would make this one 5 pi over 4. Makes this one 6 pi over 4, which is the same thing as 3 pi over 2, which will make this one over here. Whoops, I missed this one up. Sorry, this should be over here, 11 pi over 6. And then this one here would be 5 pi over 4, 6 pi over 4, so that would make this one 7 pi over 4. Sorry, I just put that in the wrong spot. So 7 pi over 4. All right, beautiful. Now let's go ahead and figure out all of these cosine and sines. Remember, this is the cosine and the sine. So the coordinates of this point, again, I went over 1, 0. This one here would be 0, 1. This one over here would be -1, 0. And this one here would be 0, -1. Okay? And then here we know that the cosine of 30 is going to be the square root of 3 over 2. And this is going to be 1/2 because it's cosine sine. The sine and the cosine of 45 are both the square root of 2 over 2, so that's easy. Square root of 2 over 2. And I know that the sine and cosine of 60 is going to be the reverse of what it's at 30, so I know this is going to be 1/2 the square root of 3 over 2. Now, if we take a look at these angles, this angle here is really the same value as this angle over here, except it's just a mirror image. It's just flipped. And over here, I have a positive x and a positive y. But over here, I'm going to have a negative x, but a positive y. So if I were to figure out the sine of this angle, well, the sine would be the opposite over the hypotenuse. Well, we know the hypotenuse is always going to be the radius, so we know that's going to be positive because it's just going to be 1. So if I'm looking for the sine of this angle, the sine would be y, which is positive, over r, which is positive. So I know in this quadrant, the sine is always going to be positive. In this quadrant, let's take a look at the cosine. It's going to be the opposite over the hypotenuse, but this would be a negative divided by a positive. So I know the cosine is always going to be negative. And in this quadrant, the tangent is going to be the opposite over the adjacent, which would be positive over negative. So this would be negative. So in this quadrant, the only thing that's positive is the sine. My cosine and tangent would be negative. In this quadrant, we know they're all positive, right? First quadrant, everything's positive. Let's take a look at quadrant 3. What happens in quadrant 3? So again, let's just take a look at an example here. Let's take a look at this triangle right here. I'm going negative x, but then I'm also going negative y. But my radius is going to be positive. So if I'm looking at this angle here, the sine would be my opposite over my hypotenuse. So it's a negative divided by a positive, so that's going to be negative. If I'm going to take a look at the cosine, it's going to be my adjacent over my hypotenuse, so it'll also be negative. And if I'm going to look at my tangent, it's going to be my opposite over my adjacent, which is a negative divided by a negative, so the tangent is going to be positive. So in this quadrant 3, only the tangent is positive. And let's do the same thing in this quadrant. Let's take a look at this triangle. I have a right angle. This is going to be positive. My radius is going to be positive. But now I'm going here in a negative y direction. So if this is my angle, I go sine, cosine, and tangent. Right? My sine is my opposite over my hypotenuse, so it's a negative divided by a positive, so this would be negative. My cosine would be my adjacent divided by hypotenuse, so it's positive and positive, so that'll be positive. And my tangent is my opposite over my adjacent, so it's a negative divided by a positive, so that'll be negative. So in this quadrant, only the cosine is positive. So here, all are positive. I'm sorry, I'm just going to reach for a marker here. In this quadrant, all is positive. I'll just use red pen. So in this quadrant, all are positive. In this quadrant, only the sine was positive. This quadrant, only the tangent was positive. And in this quadrant, only the cosine was positive. So there's a little acronym that remember this, ASTC, all students take calculus, or Alvin, Simon, Theodore, Chipmunk, or whatever you want to know. But we can now fill in all the values going around this circle because I know that these values are going to be the same as these values, except the sine will be positive and the cosine will be negative. So this is going to be square root of 3 over 2 and 1/2 because it's the same angle, it's just reflected. But now the sine is going to be positive, but the cosine is going to be negative. So remember, it goes cosine sine, so my x value will be negative. This one here is going to be the same as this one, square root of 2 over 2, but this is going to be negative. And in this one here, this is going to be the same thing as 1/2 square root of 3 over 2, but this is going to be negative. Now, if we keep going around the circle, these values, well, let's go this way first. So this one and this one will be the same thing. This will be the square root of 3 over 2 and 1/2. This and this will be the square root of 2 over 2. And this will be 1/2 square root of 3 over 2. But now only the cosine is positive. So now my sine, which is going to be my y value, will be negative. So all these second ones are going to be negative. And in this quadrant, only the tangent is positive. Your sine and cosine are going to be negative. So these will all be negative. Square root of 3 over 2 is negative. Negative 1/2. Negative square root of 2 over 2. Negative square root of 2 over 2. And this one here is going to be negative 1/2 and negative square root of 3 over 2. And that's how you fill in your unit circle.